Janet, take it away.
All right, thank you. Good morning. My name is Janet Spruill. First, I'd like to thank the Office of Naval Research, NAWCTSD, and the Tech Grove for sponsoring this challenge, and really for having the foresight to envision the impact that generative AI will have to greatly accelerate both the development and the modernization of Navy training. This competition has been a natural extension of the work that Aptima has been leading for several years at DARPA and ONR, where we've advanced combining the science of learning with engineering and AI. And our team that you'll meet today brings together some of our most accomplished technical and thought leaders in all of those disciplines, plus deep and current expertise and experience in ready relevant learning in the Navy training process. Over the last 8 weeks, our team has not only met the challenge, but we've exceeded even our own expectations to identify some additional recommendations for the process that we look forward to discussing with you. So now it's my pleasure to hand off to our team's incredible leader, Dr. Bob McCormick. Bob?
Thank you, Janet, and thanks again to the challenge sponsors for this great problem. And of course, a huge thank you to the team here, without which this would not have been possible. I do want to point out, full disclosure, a lot of the imagery in here is generated by AI, including our backgrounds here, and the nautical logo. Okay. So today's rapid technology proliferation has rendered legacy training life cycles misaligned with modern warfare demands. Development cycles can extend years and struggle to assimilate capability advances in time for personnel to gain proficiency. Current ISD frameworks rely on tedious human workflows with heavy analysis overhead. Just formulating essential models like task and learning analyses can consume thousands of manual hours per role with limited scalability. The resulting capability delays significantly obstruct deploying modernized training programs, and the gaps are only going to intensify as technology complexity compounds. So our solution, Nautical, or the novel AI utility for training, instruction, comprehensive analytic learning, represents a new capability that profoundly amplifies Navy training development and analytics. Through thoughtfully engineered automation, Nautical transforms instructional systems design while upholding personnel readiness as the cornerstone. So let's walk through some of these solution components that we have outlined here. First,
I'm sorry to interrupt you here, but I don't know if you're seeing your screen on our end, the resolution of the screen, it's not all showing on the screen. Maybe you could refresh your share.
Oh, is that any better?
No, for some reason, and I don't know why it's doing that.
It looks good to participants, I think.
And on your end?
Are you able to go to view options at the top?
A little bit more. Yeah, I was looking at the time. Yeah, we stopped. 17:16.
Folks are weighing in. It looks good online.
Just yeah, let me know when ready to resume.
That's the percentage.
No.
At the very, very top.
All
right. Well, okay, there's always a first. All right, Bob, you get an extra 40 seconds.
I'll use every second.
Excuse me, a minute and 10, yes.
All right, thank you. Yeah, so I want to introduce some of the main components of the Nautical solution. So first is a set of intuitive browser-based interfaces custom designed to support ISD workflows. This environment minimizes disruption by integrating AI augmentation into existing practices that ISDs already know. Nautical, at its essence, is a collaborative AI agent that is an expert in how ISDs do their job. Next, Nautical's pioneering prompt engineering strategy steers advanced natural language models to generate high-fidelity artifacts with incredible precision and transparency. By structuring data and applying techniques like retrieval augmented generation and chain of thought reasoning, response relevance is maximized across an incredible scope of analyses. System is powered by a robust data model, that decomposes the products into adaptable fields. The modular architecture affords immense flexibility to incorporate innovations as capabilities evolve, essentially future-proofing Nautical's design. Finally, Nautical's enhanced integration tools empower analysts to access contextual explanations behind every AI-generated data point. By coupling outputs with underlying rationales, Nautical enables informed evaluation to continuously strengthen trust and output quality. In effect, Nautical combines efficiency gains with transparent AI governance. Coming into this challenge, we evaluated a lot of large language models. In fact, we've been in the large language model space for at least 4 years, going back to GPT-2. So we already had a pretty big library of models that we were comfortable working with. And we were able to quickly narrow the list down to these 4 models. And our selection criteria for what to use came down to a number of items that you see here. So first of all, is it commercial or is it self-hostable? Is this something we can completely control within our own environment? The size of the context window, that determines how big the prompts can be and how much information we can put into our questions. The ability to respect output formats. Does it give us the answers in the way we want to see them? And then is there a specific task upon which the models were trained? Like, are they specifically a chat agent, a question and answer agent, a completion agent? And then, of course, ability to access the model through an API. At the end of the day, we chose not to decide. We said we need to leverage all of these models, and we need to make this future-proof so we can leverage future models. So what we did is we developed an API gateway that allows us to access any of these models. And at the individual data cell level, we can choose which model is going to be most effective. So in terms of how does the AI arrive at a solution, we start with first the end goals in mind. What are the analysis products we want to create? From there, we employ a structured data model that deconstructs the analysis into customizable fields and enables LLM prompts to target discrete elements of the products. Prompt templates enable reusability across items, tasks, and ratings through easy-to-use dynamic scripting. Advanced techniques such as retrieval augmented generation and chain of thought prompting are made simple through an intuitive workflow. RAG enables structured external knowledge to provide context that informs responses. Chain of thought prompting decomposes complex queries into discrete steps, either within a single prompt or across multiple prompts, or sometimes both. To use the system, prompts bound responses to further enhance accuracy. Large language models then produce structured outputs guided by the prompt template format specifications within Nautical. Integrated rationale and explanations of responses add transparency, and with validation built into the process, ISDs can continuously refine and tune prompts to produce results that improve over time. Finally, once prompts are tuned and validated, batch generation automatically produces documents in one fell swoop, enabling rapid application to new jobs, duties, and tasks. Integrated formatting tools allow both answer and rationales to be exported to Excel and Word documents. In terms of software and hardware dependencies, so Nautical is built on a modular framework that incorporates several interconnected technologies. In terms of software, probably the nucleus is going to be the LLM access gateway that allows us, as I said, to be able to access any language model, including self-hosted ones like Llama 2 or commercially available ones. We use a number of other technologies that you can see here as well. In terms of hardware, we have a scalable solution. So we can run this completely off an individual laptop as long as it has sufficient VRAM capabilities, and self-host a Llama 2 model as well as the application. And we can scale this up to a larger environment and use the biggest and best commercially available tools as well. Of course, the quality of results is gonna scale as well. So for smaller models that are self-hosted, we wouldn't expect as good of results, but in some cases, security may trump those considerations. Okay, so the requirements for the implementation and deployment of Nautical include the inherent knowledge of the large language model that it was trained on, but also we supplement this with any number of additional documents. So these could be ISD guiding documents that help them understand the process, as well as lookup tables that they may need to use in that process. Any information on the rating, this include manuals, other documentation, previous training, this can all be uploaded into Nautical and accessed either directly or through retrieval augmented generation. In terms of training users how to use the system, we envision about a week of training, 2 days introductory system training, 2 days of basic prompt engineering for ISDs and analysts, and then 1 day focused on some of these advanced techniques like RAG and access to data sources and chain of thought prompting. Rigorously validating AI system performance across multiple dimensions was integral to Nautical's development from the inception. I won't read through every word here, but I want to point out that iterative testing was heavily employed to improve prompt formats and results. And one exciting strategy of note was our ability to utilize large language models themselves to improve the prompts. Asking an LLM how to prompt it to produce the intended results dramatically improves outcomes. This is truly a case of collaboration with the AI agents and learning how to work as a team with the agent. Another innovation was our approach to transparency. Asking the language models to produce rationales for its answers not only builds trust, but also improves the quality of the answers as well. Of note as well is our ability to test at scale, which we will illustrate in the next slide. So in the end, we produced 216 data cells across all 5 documents. When we multiply this by the number of tasks that we were looking at, we had in total on order of about 8,000 unique responses generated by the system. About 2,000 of those were generated in the last essentially 24 hours with data set 3. So technical barriers and organizational barriers that we need to overcome here include kind of integration challenges with legacy systems, concerns over data security and privacy with cloud services, and that's why we want to add the option to be able to scale down to completely self-hosted models. And there's a lot of lack of clear doctrine for managing AI-powered advanced systems at the moment, because this is a rapidly evolving field. In terms of organizational barriers, there's inertia and resistance to changing, and that's why we've really tailored this for ISDs in mind so that it's easy and understandable to use from the get-go. And again, evolving rules and regulations on the use of generative AI is always something we have to keep on top of. Okay, so Nautical is specifically designed to streamline the workflow of ISDs and subject matter experts. Traditionally, the process of conducting task learning and media selection analyses involved extensive multiple knowledge elicitation workshops. These workshops, while valuable, are often time-consuming and labor-intensive, pulling SMEs and sailors away from critical duties. By implementing Nautical, we significantly reduce the time and effort through the intelligent setup phase. Initially, ISDs and SMEs need to engage in a series of preliminary tasks represented by the brown boxes in the interface. These tasks involve crafting detailed structured prompts that guide the AI to generate precise, relevant content. Once this initial setup's complete, though, Nautical's efficiency becomes evident. The same structured prompts can apply to a multitude of scenarios, whether different jobs, duties, or tasks. And of note, our estimates are that this process can be reduced from months down to days, given the level of automation that we've introduced through Nautical. Okay, so overall assessment of challenges and opportunities. The top challenge we expect in transitioning Nautical to the Navy is addressing data security and privacy concerns. This has come up time and again. Depending on the nature of jobs, duties, and tasks, training products may require additional layers of security, and the use of commercial cloud-hosted LLMs may not be viable in all cases. And so, again, that's really touches on our scalability to privately hosted models. The second challenge is change management, which we need to actively do through training and engagement with ISDs. And then validation is needed to build trust with the user, the leaders, and the students who benefit from downstream training. The ultimate measure of Nautical is really the impact on fleet readiness. On the other hand, there's a number of opportunities that we're really excited about. So first is the accelerated path to training modernization. What takes months to years can now be reduced to weeks using Nautical. Second is the opportunity to expand Nautical to cover the entire training cycle, from job analysis to training content development and delivery. We imagine a world where AI can generate training scenarios and content on the fly that meets the need of a specific learner at a specific time and accelerates their path to readiness. And finally, Nautical represents a very real opportunity opportunity to see human AI collaboration in practice. So we're really excited to build off this opportunity and learn more through the process so similar systems can be implemented in the future. Okay, and now I'll switch over to our demo. So when you open the Nautical app, you're greeted with this screen, and across the top, we have a number of tabs that mimic the ISD workflow. So from setting up a project, defining tasks, and then we have a set of twin tabs here, product items and product templates. This is where you define the meat of the questions that you want to ask the LLM. We can also bring in external data sources, set up reg workflows, and then generate responses for individual items to test and iterate and self-reflect on how well the LLM is answering questions. Once we feel comfortable with that, we can batch generate and and export to the documents that the ISDs need. So in terms of project setup, we can name it, give it a system prompt. System prompts help focus the models on providing answers with accuracy in the formats we need, and really tell them how we want them to act. We can set up our tasks. So here we have the 54 tasks from the challenge. We select one, we can see what each task is. And then product items is really where the heart is. So here we're showing a product item for one section of the IPRD. And here we can break down, decompose the system into different things like instructions, constraints, definitions, examples of how we want the answers to look. We can also set up dependencies by adding links to other items and other documents. So we know the IPRD depends a lot on what's the information developed during the learning analysis. So we can directly pull that information generated by AI into other things, creating really a web of dependencies here. The prompt templates, we use a dynamic scripting language called Jinja. And this allows us to reuse prompts across any number of ratings, jobs, duties, tasks. So going in here, again, we define a product template, and we have a number of strategies. So far, I've only been talking about AI-generated responses, but in reality, we use a number of different approaches. Some items are just copying and aggregating from other pieces of information, so we can do that. We can do manual input if the ISD just wants to put the answer in directly. Or for advanced users, we have the ability to enter and run Python code for more advanced data analyses. For each item, we can select a different model, large language model to use here. We can add reg templates and workflows. We can add specific data sources. And then coming down here, we essentially have a fill-in-the-blank template. So each of these double bracketed things is a variable that points to another piece of information in the system. And when you go to run this, and we fill this in, all that information gets entered into that prompt template to create the full prompt. And in this case, for the IPRD, we're asking it to aggregate across tasks, take all the information, and develop essentially the learning plan, the set of modules and learning objectives. Very important here is the rationale that comes along with this. So we want to know why the LLM thought that was the correct answer. And again, this builds trust with the system. The ISD can then go in, accept, reject, or accept with modifications, add rationale for their decision. That data goes back into the system to train the model to produce better answers in the future. Once you've got this set up and you have a good set of prompts, you can then turn to batch generation, where you can run all the documents at once, and this respects all the dependencies that are set up. And then you can export to Excel or Word. So I'll show our learning analysis. Again, this is our learning analysis is completely filled in through the system. This is generated automatically. And what's nice here is hovering over any specific cell shows the rationale behind that decision. So if ISDs prefer to work with these worksheets, they can export them and they can see the rationale behind every decision here. In the IPRD, let me switch to that. Again, this is completely generated from the system, including all the content, formatting, and data, as well as all the images. So things like graphs like this, these are automatically generated with the right numbers. We have the ability to upload flowcharts or attach images to specific product items that get added in here. And if we go down to the item we were looking at, 453, we can see the content from the system now put into the document. So I believe I'm almost out of time, so I'll switch back here. And leave you with this screen here. Why nautical? You know, we really believe it's built for the ISD workflow. It's truly a collaborative thing. So it understands how ISDs work, and it blends what's best about the AI, what's best about the human into a comprehensive solution. The customizable and extensible modular architecture essentially future-proofs nautical, so we can bring in new language models and new results.
And with that, we are at time. I know it's like 30 seconds maybe. So, but
All right, thank you all. Thank you, Bob.
thank you very much, Aptima team. And next we will transition to our last presentation, which is the adaptive